So the second type of normal distribution problem that we might have is the backward normal kind of problems. So in this case, the setup of the problem is the same. We're still talking about the blood cholesterol of these 14-year-old boys, and we know that that population has a mean of 170 and a standard deviation of 30. And this time they want to know, how high does a boy's cholesterol have to be for him to be in the top 10%? So the first problem that we looked at gave us an X value, 240, and our answer was a percent. We wanted to know what percent of boys were greater than 240. So they gave you an X, answer was a percent. In this case, it's backwards, okay? We have the opposite. So they're giving us a percent, 10%, and our answer is going to be an X value. So I'm just going to start by writing down again what I have here. So X represents blood cholesterol levels for 14-year-old boys. And it tells us that X follows a normal distribution with a mean of 170 and a standard deviation of 30. So now I'm going to go ahead and sketch a picture of what it is that I'm trying to find here. So here's my normal distribution. And I'm just setting it up. If you watch the first video about the regular problem, then I explain a little bit more about where I'm coming up with all these numbers that I'm writing down here. Okay, so in this problem, they don't give us a value here, an X value, so I'm just going to kind of write a dotted line. But what they do tell us is that above that line, so here's kind of a dotted line because I'm saying I don't know exactly what value of X that is. That's what I'm trying to find. But above that line, I do know that the area is 10%, okay? Or in decimal form, that would be an area of 0.10. All right, so now that I have my picture, this is a backwards normal problem, so I flip-flop the next two steps. Okay, I start with my percentage, I go to the table first, I find a Z value in the table, and then I kind of reverse solve to get my X value. So thinking about the table always gives the percentile or the area to the left. So let me write that down. So table always gives the area to the left. So looking at my picture here, I know that the area to the right of this mystery X value is 10%. So if there's 10% to the right, then to the left there would have to be 90%, or 0.90. That was an or. So when I look in table A, I'm going to be looking for the percentile closest to 90%, because if you're in the 90th percentile, then you are in the top 10%. So we're going to look in table A for percentile close to 0.90 or 90%. So here's my table A, and I'm looking in the middle section of the table for, that's where all the percentiles are, for the closest one I can find to 90%. If I look at all of them, I can see that the closest percentile to 90% is this one right here. It's 0.8997. So this is the closest I can get to the 90th percentile, or in other words, being in the top 10%. So from here, I look at the values on the row and column to find out what that corresponding Z value is. So for the 90th percentile, the Z score would be 1.28. So back here, my Z then is 1.28, and I know that a Z score is calculated by taking an X value, subtracting the mean, which in this case is 170, and dividing by standard deviation, which in this case is 30. So now I have just an equation with just one unknown value, and I can go ahead and solve for X. So I start by taking that 1.28 and I multiply that by 30. When I do that, I get 38.4. That's going to be equal to x minus 170. Okay, now I'm going to add 170 to both sides. And I get 208.4 is equal to x. And that's my answer. So to be in the top 10% of boys, you would have to have a blood cholesterol level of 208.4 or higher. So of course I'd always write my sentence stating my conclusion. So boys with cholesterol of 208.4 or higher are in the top 10%.